Just a moment, please. I'm sorry.
Don't worry, we still have time. Yeah.
I guess. How about this? My screen?
Okay. Yeah, we can see your screen. Yeah, please start now.
Okay. Hello, everyone. I'm Hiroaki Saito, U Tokyo, and my title of talk is Observations of Structure and Dynamics of the Kuroshio Ecosystem and the CSK-2 project. Just a moment, please. Sorry, something wrong. Just a moment, please. I'm sorry.
Yeah, it looks very beautiful at that point.
Can you see my screen?
Yeah, yeah,
okay.
Sure.
Okay, thank you. Sorry. So at the beginning, I want to talk about the history of biological oceanography, and the beginning of biological oceanography is for fisheries to clarify the mechanisms of stock fluctuation of herring, and it was developed to understand process and dynamics of biological and fishery production. So most of the early phase of the biological oceanography studies are in the coastal and the continental shelf regions such as North Sea or Baltic Sea or George Banks, and also upwelling regions such as Peru, California, or Venezuela. And these regions are characterized by high nitrate input and high chlorophyll. My voice is okay?
Okay, yeah, clear.
Okay. And the other part of biological oceanography recently developed well is a subtropical gyre, like Station Hot and Station Aloha of Hawaii. And these are very unique ecosystems compared with coastal or upwelling region, characterized by depleted nitrate, strong thermocline, and nitrogen fixation. These regions are very, very low fishery production. It is often called ocean desert. Kuroshio, it's an oligotrophic, but high fishery production. Yeah, as you know, Kuroshio is a western boundary current of the North Pacific, and the transport large amount of heat, salt, chemical materials, and organisms to the north, like this. And this is a transport oligotrophic subtropical waters. The Kuroshio, name of Kuroshio, many of you may understand this Chinese character, is a black or dark ultramarine water, meaning low chlorophyll concentration. But the Kuroshio region is very high fishery production. Many species of fish and squids use this Kuroshio region as a spawning and nursery ground And in Japan, almost 60% of the fishery production is from this Kuroshio species, using the Kuroshio ecosystem as spawning and nursery grounds. This is some kind of the comparison between Bering Sea Oyashio, Perapurain, Kuroshio, and Station Aloha subtropical. Bering Sea Oyashio, Perapurain, this is very high nitrate concentration in the surface, and the chlorophyll concentration very high. Perapurain is a little bit lower, but the fishery production very, very high. Station Aloha subtropical gyre, the nitrate concentration is usually less than 10 nanomole or around 10 nanomole, and the chlorophyll concentration is usually less than 0.1 milligram per cubic meter. The fishery production very low. Kuroshio, in the late winter, Kuroshio nitrate concentration is about 1 micromole, but just several weeks. In summer, spring, nitrate concentration can be 10 nanomole, very low, like Station Aloha. And the chlorophyll concentration is 0.1, 0.2 most of the time of the year. This is similar to Station Aloha rather than Bering Sea Oyashio. But Kuroshio region is very high fishery production. So why so high fishery production in the eutrophic water? I named this inconsistency, high fishery production in the eutrophic water, as Kuroshio paradox. And we started study about to solve the Kuroshio paradox. And we have two key questions. One is the mechanism of the nutrient supply and the consumption. And the second is the food web structure transporting primary production to fish larvae juvenile. And this is a cartoon I often use. Kuroshio often change their strength, path, or they sometimes meander a lot. And this influence the nutrient supply and change the ecosystem structure and the productivity and change fishery production. To understand these physical and chemical biological processes, we made a team of scientists to understand these processes. And research component of this SCET program. SCET is a study of Kuroshio for ecosystem dynamics for sustainable fisheries. Most of people working in the field or in the laboratory, especially physical oceanography, is targeting microstructure using CTD or TurboMap or underwater CTD or underwater microstructure profilers. And other scientists are working on phytoplankton or zooplankton fish larvae and their species composition or production or fish larvae growth or some competitor of fish species targeting to the fisheries. Another scientists are desktop working on the satellite oceanography to examine phytoplankton biomass and phytoplankton groups or sites. And several physical oceanographers using the ocean general circulation model or LOMS, very high resolution, less than 1 kilometer in resolution. And EcoPath with ecosystem model. And also we also have a fisheries economist to understand how ecosystem change influence our society. Anyway, most of the results have been published in this Kuroshio current book, published from AG Monograph, AG Wiley last year. So if you are interested, please check this book. So in this session, I want to show just a brief result because very limited time we have. One is the physical processes of nutrient supply. We hypothesize that there should be a package of nutrient supply mechanism in addition to winter mixing, like topography or bottom Ekman layer, island effect, or turbulence, or from continental shelf, slope, or some dust flux. And our physical oceanographer team carried a very nice job this a little bit. This is from northern Philippines, Taiwan, and Japan, and this is the path of Kuroshio. And there are several different process mechanisms to supply nutrient. And in the Tokara Strait, Kuroshio passing through shallow strait. In this strait, 5 gigawatt dissipation of turbulence and about 10 megamole nitrogen per day supplied in this region. And in the Kuroshio front, Kuroshio extension front, double diffusion supply nutrient at this area, and this diffusion rate is like this, very high. And also turbulent dissipation happened. And the northern part of the Kuroshio extension, mesoscale induction supply huge amount of 1 gigamole nitrogen per day. So this area is very, very productive region, or Kuroshio ocean mixed water region in wintertime. The other findings are phytoplankton composition. This is one of the example. South of Kyushu. In oligotrophic water or subtropical gyre, Prochlorococcus or Synecoccus sand bacteria are dominated. But in the region, haptophyte and green algae are most dominated, and the diatom is a minor component. So presence of haptophyte or nanophyte plankton size is about 3 micrometer or 5 micrometer is indicated that the Kuroshio ecosystem is mesotrophic or not perfectly nutrient depleted water. Occasional nutrient may supply some time, but not so high rate. So non-phytoplankton dominated, and the diatom or microphytoplankton was minor component. Fisheries production usually depend on copepod and diatoms. Copepod can feed on this zooplankton, very important prey for fish larvae, juvenile. They can feed on phytoplankton larger than 10 micron, like diatoms. But the dominant phytoplankton in the Kuroshio is nanophytoplankton and cyanobacteria. So less than 10 micron are dominated. But dorioid appendicularия or tunicate can feed on this small phytoplankton. And this, so, but Sarpa or dorioid appendicularия is not very good prey for most fish larvae juvenile. But some copepod, like a saphirina, maybe some of you know this copepod. This is very beautiful organisms. They feed on dorioids. This is a underwater video plankton recorder images. Saphirina is usually attached on dorioid and feed on them. And the other example is Onkea. Onkea is other copepod. And Onkea feed on appendicular house. This is a movie, and I want to speed up like this. So Onkea feed on discarded house of appendicularia. So Onkea is very, very important prey for fish larvae juvenile. So nanophytoplankton production is transported to tunicate or appendicularia or dorioid at first, and then transported to copepod and then fish. This is a study by Okazaki that red shows poikilostomatoid copepod. Many people are not familiar with poikilostomatoid copepod, but like Onkea or Onkea species or Corkis or Saphirina species, and they are very important prey in many stations. And also other caranoid copepod, Brachyuranus, the Corascanus, are also very important prey for juvenile fish. So in the Kuroshio, both caranoid copepod and Onkea or poikilostomatoid copepod are very important. to transfer to, I'd say these components are very important to transfer phytoplankton production to fish. This is a cartoon about Kuroshio ecosystem food chains. There are many food chains. Grazing food chain like a diatom to cranocopon and fish larvae is very important, of course. But in the same time, tunicate food chain, Okazaki proposed that the Doriolid appendicuaria feed on non-phytoplankton, and the Onkia species, the Sophinia species, are fed by many other species. And some also the other species prefer also this is mixed fish larvae prefer ostracod, the other zooplankton, and the other fish prefer other zooplankton. So Kuroshio ecosystem is fishery production in the Kuroshio ecosystem is supported by many food chains, not only one, not very simple, very complex. This is a summary figure of the nutrient supply and the ecosystem, that food web dynamics in the Kuroshio region, published my paper. And in winter time, because of winter mixing, small amount of nitrate is supplied. And microphytoplankton like diatom increase, and the cranocopod increase like paracaras or crasscorns, and the fish larvae feed on them. This is grazing food chain. This is a well-known food chain, but this continue only 3 weeks, 4 weeks, very short. Most of the time, other than spring, small amount of nutrient supplied to the euphotic zone, and picophytoplankton and phytoplankton, cyanobacteria or haptophyte increase. And these small phytoplankton are fed by appendicuaria, doriolid, tunicate, and they are fed by poikilosomatocopod like Onkia species, zooplankton, or directly fed by some specific fish species. So we say tunicate food chain are dominated in spring, summer, or autumn season. So we found many new findings, but still we have remaining issue about the ecosystem of the Kuroshio. Why the quantitative estimate of seasonal and geographical variation in new production. Nitrate supply and new production is very essential to transport primary production to fish species, fish or squid. Second question remaining issue is a quantitative estimate of new nitrogen transfer process through grazing and tunicate food chains. We know there are several food chains, but our data about understanding about the quantitative estimate is not perfect. So we want to continue to study quantitative estimate of the new nitrogen transfer processes. And then number 3 is the influence of physical fluctuation of the Kuroshio, meander, or changing salinity or everything. Influence of the fishery and the ecosystem service, and then society. And next, I want to talk about international collaboration in CSK-2. As I mentioned, there are many nutrient supply processes, mechanisms in the Kuroshio and Kuroshio. But this is very geography or topography dependent. And there are several nutrient hotspots along the Kuroshio, like a meander of Honshu or Tokura Strait we studied, or Kerama Gap is very important, but the northern tower upwelling is very important. And the north-south movement of the northern equatorial current of Philippines is very important to think about the total nutrient concentration transport by Kuroshio and in the mesopelagic layer. So these regions are in EEZ of many countries. So we need collaboration, international collaboration, to understand Kuroshio ecosystem dynamics and impact of the change of the Kuroshio through nutrient supply. The other way is the bioalgal floats. Now the bioalgal floats is getting better and better. And we can put many sensors like O2 or nitrogen or chlorophyll, of course, and like a scattering meter for particulate organic carbon or DOC. And this is a very, very early study of myself and Ito-san carried out using the temporal change of the some chlorophyll concentration and some chlorine. And this data is very, very useful to understand the seasonal change of the Kuroshio ecosystem and fishery production, because of the spring bloom period in this region is a very important period of the sardine anchovy nursery or growing season. Juvenile sardine anchovy growing period. So prey concentration in this region is very important to think about the fluctuation of the sardine anchovy fluctuation, and also Jack mackerel and other species. The other issue is biodiversity around the Kuroshio and the impact of global warming. Because Kuroshio region is a very, very rapid increasing sea surface temperature. And the Kuroshio region is also very important hotspot of the biodiversity. This is a fish species, and originally in the tropical area or coral triangle areas, and some of this fish species are transported around Kuroshio, and this figure is genetic diversity, and you can see along the Kuroshio some new genetic characteristics appeared, and we can see some kind of transported history of this fish species around Kuroshio. And in the global warming, this species composition or genetic characteristics will change because of the increasing change or as a factor like a wintertime temperature or something. So now biodiversity is a very important issue for marine ecosystem under the global warming. And we have a DNA environmental DNA technique. This is not very difficult. And so it is very easy to apply this technique to understand the change of the biodiversity for everything. This is not only for fish, but in U-Tokyo Aoi Atmosphere Ocean Research Institute, we prepared a meat-fish database because we don't have very nice database, DNA database for marine organisms. We need to develop very nice DNA database, not only for fish, but also plankton or coral or other organisms, benthos. And in Aoi, we prepared a very nice database meat-fish, and we also prepared a meta-annotator, the MyFish pipeline. This is a very comprehensive and standardized fish mitochondrial genome database, and including whole genome data of almost 3,000 species, and the partial genome data is about 30,000 species. And more than 700 papers are published using this meat-fish database. We need to develop this database under the international collaboration. In the scheme, we need transfer of marine science technology, maybe using a summer workshop or summer course. And this is, I think, using the, also, if we use, very important is using identical methods. It is very often that contamination of the DNA is very, very common because of the not very well cared sampling or analysis method. So we may need some kind of summer course or workshop to use identical method for eDNA and the other marine science technology. In U-Tokyo Aori Atmosphere Ocean Research Institute, we started Ocean DNA project. And this is targeting from bacteria, microbiology to marine mammals. And we are collecting many water data, including DNA. And we are now developing the DNA database. And finally, we want to make a biomap, like including community structure or response of organisms to change of the environment and special temporal variation and for modeling. And this is maybe very important for forecasting the future of the marine ecosystem in the Kuroshio or future resources, fishery resources, futures of the fishery resources. This is different from CSK-2, but now we have I'm carrying out some CREPSAM JSPS program. This is a collaborative research and education project in Southeast Asia for sustainable use of marine ecosystem, including Japan, Philippines, Indonesia, and other Thailand, Vietnam, Malaysia. This is not only for Kuroshio study, but I guess we can use this CREPSAM project for transfer of marine science technology, including eDNA technique. For Kuroshio cruise, we carry out this cruise 2015, and next September we also have a Hakoma cruise. This cruise was planned in July, but because of COVID, it was at first canceled, and now schedule changed, and it is scheduled to start from September 10 to carry out interdisciplinary observation along the Kuroshio. And we also, this is still planning phase, but we are planning a CSMR cruise next year, summer 2021 to Strait, Amami Oshima Island, and this is also interdisciplinary project. And I guess we can use this cruise for some CSK-2 related activity. Okay, thank you very much. That's all.
Okay, thank you, Hiroki. And is there any question? Please go ahead or just raise your hand. Is there any question? Yeah. If anyone has question, you can use the button in the middle and raise your hand. Okay, yeah. Please go ahead.
May I ask one question?
Oh, yes.
So thank you very much. Very informative talk. So my question is maybe related to the seasonality of the Kuroshio ecosystem. Your first slide shows that there is maybe a dust effect.
Okay.
So my question is, how important is the effect of the dust and the effect of river discharge in the summertime?
Okay. River discharge and the dust event. This is a kind of new production from terrestrial area, and this is very important in very coastal area, especially river discharge is very important in coastal area. But our modeling study shows that most of the nutrient in coastal region along Japan, or Japan is nutrient is come from Kuroshio subsurface area, and contribution of river discharge nutrient is very low along Japan. But of course, this is very important in the East China Sea, and dust So importance of the river discharge and the dust event is depend on the region. And but in the Pacific area, dust or river discharge influence is not so very high. The other important influence of dust event is nitrogen fixation, and this is probably very important to increase summertime or autumn time nitrogen production in the surface layer through trichodesmine nitrogen fixer production. And but nitrate flux, impact of nitrate flux is not very well studied in this region. Maybe, yeah, this is I guess, this is the issue to be solved in the future. Thank you very much.
Okay, thank you very much.
Okay, thank you, Hiroki. Is there any other question? Is there any question? So next time, I also have a question.
I'm sorry, I can't hear well, and very noisy something.
Very noisy?
Yeah, something background noise.
Yeah, maybe my background is noisy. Is better now? Hello? Can you hear me? Hello? Hello? Could you hear me?
Oh, yes.
Oh, yeah. My question is, since the crucial reason is highly affected by some climate variability, do you have any idea about how the chemical variability associated with the climate change, not only global warming, but other like decadal climate change?
Your question is impact of climate change?
Yeah, like from annual to decadal time scale climate change. Yeah.
Okay, this is Ken. We cannot hear your voice.
And a very noisy background. Someone's might catch some other people's voice. I'm sorry, Shafe, I'm asking you, your question is impact of climate change on?
Yeah, other climate change, like annual to decadal climate change.
Oh, okay. Kuroshio ecosystem is very influenced by climate change, especially the, how to say it, decadal or bidecadal change, and especially Kuroshio path is sometimes very straight, but some year very meander phase, like a spaghetti, and this influence AD activity in the Kuroshio and the Kuroshio extension region, and influence of nutrient supply very much. And in very meander phase, many AD are formed, and usually nutrient supply is very higher compared with straight path phase. And this may influence the primary production of the Kuroshio region. Also, many AD formed along the Kuroshio extension region is a return to the Kuroshio area by the recirculation of Kuroshio, and this is influence of the productivity of the southern part of the Kuroshio region, like Kyushu or Okinawa area, and so influence of the sub-mesoscale AD on the productivity of the Kuroshio is also the other issue to be resolved in the future.
Thank you. Sorry for the noisy background here. Yeah. Is there any other question? Yeah, Joey, please go ahead.
Thank you, Sato-san. I have a question following Xiaopei's question. Yeah, the Kuroshio extension actually is expected to move northward if we check the climate model result. So if the Kuroshio extension move northward, does it have any potential effect to the local fishery ground or fishery productivity?
Of course, yeah, we know several models forecasted the northern migration of the Kuroshio extension front, and the other model is still keeping the position of the Kuroshio extension. So I'm not quite sure which one is the real future, but if Kuroshio extension move to north, this is very, very influential to the fishery production and the fishery migration route, because many fish species using the Kuroshio extension region as a nursery ground, and many fish egg larvae are transported to Kuroshio extension region. If transported to the Kuroshio extension move to north, it is expected that fish larvae juvenile stayed low prey concentration region many days, more days compared with at present, and also primary prey production is estimated to be lower in the region. So northern shift of Kuroshio extension may influence fish production a lot. And this is also the fish species distributed in the northern part of the Kuroshio extension, because of the Kuroshio extension, northern part of the Kuroshio extension region is some kind of the mixed water region, and this area nutrient is the influence of the mix of the Kuroshio and Oeshio. And if Kuroshio is stronger than present today, may transport low nutrient water to the north, and this may influence the productivity in the region and may influence the growth or growth rate of fish species distribute northern part of the Kuroshio.
Does it mean that the total catch of fish in this region may decline, or we don't know?
This is a very difficult, good question, I think. And fishery production is largely depend on the survival rate of the fish larvae juvenile, but this is also influenced by the carrying capacity or region, appropriate region, area, or how to say, area of the appropriate region to growth. If Kuroshio extension move to north, maybe some species is very, very happy to increase their appropriate region, but some species are not happy because of the shrinking the appropriate region to survive. Yeah, it is.
Thank you.
Yeah.
It's hard to say, yeah. Thank you.
Next question, Tanya. I found you have raised your hand.
Okay, thank you, Xiaopei. It is very interesting for me regarding your nice presentation. Professor Saito, could you explain more detail about tunicate food chain? Mm-hmm. And I mean that tunicate food chain is what impact, or how about the fish composition in the tropic level according the tunicate food chain? Maybe there are several juvenile have the feeding habit or more preferent food, something like that, according to tunicate food chain. Thank you.
So your question is tunicate food chain, food level of tunicate, or?
That's right. That's right.
Yeah.
That's right.
Tunicate is feeding on phytoplankton. So food level is a second or primary grazer or secondary producer. And important of tunicate is increasing size of the organic matter. Phytoplankton, non-phytoplankton or phytoplankton are not possible to be used by many zoocopod they are very important prey for fish. Fish need usually copper, and so appropriate size of prey is very important. Production of the appropriate size of fish larvae juvenile is very important. So tunicate itself is sometimes too big for many fish juvenile larvae, but some specific copper like Copeponcea or Saphirina feed on tunicate, and this is a very, very appropriate prey for fish. So tunicate itself is a secondary producer or a grazer, and this is same as microzooplankton, but tunicate is a very nice mechanism to increase size of organic matter, and this is very useful for the production of fish prey.
Okay, thank you, Kuroshio. And since time is limited, we will move to the next speaker.
Okay,
and
thank you
so
very much.
Thank you. So the next speaker is Masami-san, and his talk is about the observation of air sea infection in the crucial regions, climate hotspot 2 project in Japan.
Yeah, thank you very much.
Yeah, please share your screen.
Yes.
Yes, we can test your screen. Yeah.
Yes, thank you very much. So, my name is Masami Nonaka from Jamstack. So today I'd like to introduce the observations of air interaction in the Kuroshio regions in our climatic hotspot 2 project in Japan. This project is for molecular air sea interactive variability and its predictability. This project is rather a nationwide project in Japan, and we have more than 75 collaborators. So can you see this plot and the pointer? Can you hear me?
Yes, yes.
Okay, yeah, thank you very much. So this plot shows the sea surface heat flux in January from the ocean to the atmosphere. So here we can see huge amount of heat release from the ocean to the atmosphere in the western boundary current regions, in the Kuroshio region and also Gulf Stream region. And we call these regions as climatic hotspots. The impacts on climate have been shown by accumulated studies, including those by our first climatic hotspot project in 2010 to 2015, led by Professor Hisashi Nakamura, University of Tokyo. This figure is obtained from the Li Xin-Wu et al. 2012, and this plot shows the global SST trends over the last century. Here we can see the enhanced warming trend in the western boundary current region, again, Kuroshio region, Gulf Stream region, and so on, which could affect atmosphere aloft through the huge amount of heat release, as we found in the previous slide. Actually, these
time series shows the interannual variability of the annual maximum of hourly precipitation in Japan in the top panel, and also area mean SST anomalies around Japan in the bottom panel. So here we can see that associated with SST warming, extreme weather events are increasing in Japan. And actually we had such extreme events in the last month again. The prediction skill of such extreme events are, however, still limited due to our limited understandings of its mechanisms. Then, in our climatic hotspot 2 project, this is a 5-year project started last year. We will further our understandings of mid-latitude ocean atmosphere interaction processes. And also, based on this, we will investigate predictability of extreme weather and predictability of persistent atmospheric circulation anomalies that include and that induce those extremes. And also, we are going to investigate active roles of mid-latitude oceans in those phenomena in projection of climate changes. The bottom 2 topics, of course, basically will be conducted by the numerical studies, but in the first one, we also include the observational studies. And more specifically, to conduct the studies, we have induced the 3 categories based on the time scales like this. The first one is the daily to weekly time scale. So extreme weather scales. Now we are going to focus on these things. And in the second one is for the monthly to interannual time scale. So you're going to see, for example, interannual variability in the monsoons, May fronts, and so on. And the third one is the decadal to century time scale. So we are going to see the global warming and its influences. So in our projects, we are going to investigate ocean atmosphere interactions in these time scales, each of these time scales. At the same time, the scale interactions are also very important topic. And we are going to investigate modulation of magnitude and or frequency of extreme events through changes of background with the global warming and the climate changes. To conduct these investigations, we have the 9 main groups and 9 additional open researches, and 4 of the 9 main groups will conduct observational studies. And also 3 of the 9 additional open researches are also related to the observational studies, including the topics by the Professor Kaoru Ichikawa and Professor Hirohiko Nakamura. I guess they joined this webinar today, hopefully. But today, I'd like to introduce the observational campaigns that will be conducted by these four main groups. In our Hotspot 2 project, we will have the observation campaigns in the Tsushima warm current region and also Kuroshio extension region. First, I'd like to start from the Tsushima warm current region. So first one is the atmospheric observations at isolated islands in the Ueshio warm Tsushima current region. For improvement of forecast of heavy rainfall and snowfall, improvement of our understanding of water vapor over the ocean is crucially important, but its information is still limited, especially in the sense of the in-situ observations. So we have been conducting continuous atmospheric observations at these isolated islands whose climate is strongly affected by the ocean. We started the observations from this June, and it will be continued for nearly 4 years. And at these stations, we observed rather standard variables, atmospheric variables, like temperature, humidity, pressure, and so on. The second one is the observational campaign in the East China Sea, the source region of the Tsushima warm current. So we will have the observational campaign in summer in 2022, in the Bai season. The purpose of this campaign is to observe interactions between the SST structures associated with the Kuroshio and the Tsushima warm current and the Bai front aloft. So in that purpose, we are going to conduct simultaneous atmospheric sounding and ocean XCTD observations with these 4 vessels to make the observations across the SST front and also across the Bai front. So we are going to adjust the arrangement of the vessels depending on the position of the Bai front in the observational period. Originally, these observations were planned to conduct in June this year, but postponed to June 2022 due to the COVID-19 issue. Detailed dates are not fixed yet, and these dates are just original plan for this year. In addition to the observation in the summer season, we are going to make the observation in the Tsushima warm current region in winter time to observe interactions between the cold air flow from the continent and the warm Tsushima current. The interaction would affect the JPCZ, the Japan Sea Polar Air Mass Convergence Zone, which can induce heavy snowfall in the western part of Japan, as you can see in this satellite image. So for that purpose, we are going to conduct the simultaneous atmospheric and ocean observations. Moving under the JPCZ from the upstream to downstream with observing ocean and atmosphere continuously. And we plan 10 days observations in January 2022 and also January 2023. We believe this is the first simultaneous ocean atmosphere observations focusing on the air-sea interaction in this hotspot, climatic hotspot associated with the Tsushima warm current. In addition to the Tsushima current region, as I said, we are going to conduct observations in the Kuroshio extension region. In the summer season, we are going to have the airplane and research vessels simultaneous observations, focusing on air-sea interactions with aerosols and lower stratus clouds in summer. As you may know, the aerosols are important to form the low-level clouds as to be the nuclei of the cloud. And of course, the development of the low-level clouds are very important to the variability in the SST below. But at the same time, recently it has known that the influence of the aerosol to the formation of the low-level clouds dependent on the SST below. So through these mechanisms, the aerosol can affect the air-sea interactions in this region. So we are going to investigate this new type of air-sea interactions with the aerosol in the observations in this region. This slide shows some details of that aircraft and the shipboard simultaneous observations. We are going to have the observation in summertime 2022 in the Kuroshio extension region, where we can see the high low-level cloud amount and also the substantial influence from the anthropogenic aerosols. So in this observational campaign, the aircraft, we are going to observe the aerosol size distribution and its chemical composition, and also cloud microphysical parameters and turbulences. From the research vessel, again, we are going to observe the aerosol size distribution and its chemical composition, and also the height of the low-level clouds. From these observations, we are going to characterize the aerosols, multitude clouds, and planetary boundary layer structures, especially focusing on the similarities and differences from those in subtropics. And combining with the numerical studies and these observations, we are going to investigate roles of maritime aerosols in atmosphere-ocean interactions through the impacts of aerosols on cloud microphysics. Further, we are going to make the observation of subtropical mode water using biogeochemical algal floats. The target of this observation are understanding of detailed formation, advection, modification, and dissipation of subtropical mode water and associated biogeochemical processes in the subtropical region. Actually, we planned to deploy 13 floats, algal floats, 4 pH and DO floats indicated by these stars here, and 9 DO floats indicated by closed circles over the Kuroshio recirculation region in April, May this year, but then the cruises were canceled due to the COVID-19 issues and rescheduled in February to May 2021, the next spring. Okay, so these are the observational campaigns planned in our project. As I said in the earlier part, we of course also conducting many numerical modeling studies. So I'd like to introduce some of these examples briefly. The first one is the remote thermodynamic impact of the Kuroshio on the development of the tropical cyclone. For the typhoon Chaba in 2010, Fujiwara et al. Showed strong impact on its development, the latent heat flux from the Kuroshio region to the south of Japan, with their high resolution modeling with removal or decrease of latent heat flux over the Kuroshio region. The model results show that the suppression of typhoon development through weakened moisture import into the inner core of the typhoon. The results support that the moisture import from the Kuroshio can remotely affect typhoon development over the Western North Pacific. Another example is from Gao et al. 2020. It showed the strong numerical modeling resolution dependency of bomb cyclone characters. Here in this figure, we can see that larger number of bomb cyclones occur in high resolution models and atmospheric reanalysis. And they further showed the larger number of bomb cyclones are due to the increase of the small size of bomb cyclones that accompanied by the stronger maximum winds. So these results show the importance of high resolution modelings to understand the bomb cyclone characters, including its potential changes due to global warming. Okay, let me summarize my talk. Today, I introduced the Climatic Hotspot 2 project for mid-latitude edge interaction studies and its application to climate prediction and projection that is ongoing in Japan now. In that project, high-resolution numerical modeling studies and also several ocean atmosphere observation campaigns in the Kuroshio and the Tsushima warm current regions will be conducted as I introduced today, like this. Okay, that's all. Thank you very much.
Thank you, Masami-san. So is there any question? Yeah, please raise your hand. Is there any questions? Okay, so maybe I will ask your first question. Yes, so it's exciting that about the Hotspot 2 project. And do you have any idea about like meso to sub-meso scale reliability? We think it's also important in this region. And do you have any research plan about meso and to sub-meso scale reliability and also its related ARC interaction?
Yeah, thank you very much. Good question. That's an important point. And yes, first, for the sub-mesoscale phenomena, we are going to conduct numerical studies. Our current plan is to conduct 1 kilometer resolution modeling for the basin scale, North Pacific Ocean basin scale, 1 kilometer resolution modeling. Still, we are not sure if we will be successful to conduct that modeling, but at least still already we have the 3 kilometer resolution North Pacific basin scale model for integrated for nearly 20 years. And so based on those numerical modelings, we can investigate the details of the sub-mesoscales and also its interannual and decadal timescale variability. And we have started to see the such kind of interannual to decadal variability and found that such sub-mesoscale variability can affect the larger scale, mesoscale and the larger scale variability. And for the observational studies, in association with the aircraft research vessel simultaneous observation, we are going to conduct oceanic observations focusing on the eddies and sub-mesoscale features around the eddies to see how such sub-mesoscale features can affect the dissipation of the oceanic mesoscale eddies. So in that observation, I guess we can see it will be a good opportunity to see the possible ocean to atmosphere influence on the sub-mesoscale features. Actually, in our previous observations, we already found that atmosphere can respond to the very small 1 kilometer to 10 kilometer scale SST structures. So I hope we can see such kind of ocean to atmosphere influences on those scales. Is it, can it be the answer to your question?
Yes, thanks. And also I think it's very promising, and we wish we would have more collaboration with Joystick about observation and also numerical study in this region.
Yes, yeah.
It's exciting. Okay, so is there any question? Yeah, please go ahead. Someone now? Yeah.
Yeah, hi. This is Songhyun. I'm from Seoul National University. And thank you for introducing very nice program, new program, to better understand the LC interaction processes. My question is about one of the examples, typhoon and atmosphere interaction process. I believe Kuroshio is important not only for the typhoon genesis, but also the prediction of intensity and the path track of the typhoon. So to better understand the typhoon intensity, we need to better observational, in situ observational data to estimate, especially the latent heat flux. So my question is whether this program include field campaign to collect the data to estimate latent heat flux under the typhoon condition. So could you answer that question?
Actually, very unfortunately, so far we don't have the specific observation plan for focusing on the typhoons. Yeah, as I showed in the very last part, the heat flux from the Kuroshio can affect the development of the typhoon. So first, it's important to make many numerical experiments to confirm such kind of influence from the mid-latitude ocean to the development of typhoons. And as shown in that slide, the transport of moisture is most important for the development of the typhoon, at least in the results so far we have. So in that sense, for example, the observations, atmospheric observations at the isolated island can be contribute to such, to improve our understanding of such moisture transport over the ocean. So, as you know, it's very difficult to make the observation around typhoon. So I guess it's important to do the many numerical studies and also the continuous observations, for example, at the island, and to have a chance to have a good opportunity to see the phenomena relating to the typhoons, some typhoons.
Okay, thank you very much.
Thank you very much.
Hey, thank you, Masami. And is there any question? Any question? Okay, yeah, please go ahead. Yeah, Jai.
Okay, thank you. My question is that very much related to the previous question by Professor Nam. For Earth interaction over the bio or the MAU front, so it seems that necessary to understand the much more large-scale atmospheric phenomena to understand the background situation. So do we have any plan to study about atmospheric part, including Arctic Ocean or something like that?
Yeah, thank you very much for your question. Yes, the observation campaign itself focus on more rather smaller scale and a shorter time scale, probably mesoscale along on the biomail front. But at the same time, we conduct many numerical studies to see the more larger scale and longer scale atmospheric circulation. So in that sense, the oceanic frontal structure is important to for the development of the atmospheric cyclones and also the atmospheric larger scale circulation. So we have conducted many such kind of numerical experiments. So we believe that it's important to combine wisely the observational studies and also numerical modeling studies.
Okay, thank you very much.
Thank you very much.
Okay, so we still have a couple of minutes for questions. Is there any question?
Xiaopei,
Hey.
this is Ken. Yeah. Can I talk? Xiaopei, this is Ken. Can I talk?
Yeah, sure.
Yeah, I have a question to Nonaka-san. So for this hotspot 2, so it sounds like that you do not use the surface modeling and also autonomous platform. So very simple question, why?
Basically, due to the limited budget. Yeah, as you know very well, the surface modeling costs much. And yeah, we are very interested in such observations, especially, for example, in the East China Sea, the Kuroshio and Tsushima warm current south region. I guess it's very nice if we can have such observations, but yeah, simply due to the limited budget, we cannot do the surface observations in this project. Yeah, it's nice if some other project can do and collaborate with our project.
Mm-hmm. Okay, thank you.
Yeah, thank you very much.
Okay, so is there any question? Yes, we have one. Okay, if no, we will move to the next talk.
Yeah,
So
thank you very much.
Thank you, Masami-san. And so the next speaker is Akira-san, and his talk is about observations in the origin of the Kuroshio, a pilot study for construction of observation system under CSK-2 project. So, hi, Akira. Please share your screen.
Can you see my screen?
Yes, we can see your
okay.
screen.
Thank you, Xiaopei. Good afternoon, everyone. My name is Akira Nagano. I'm working for Jamstick. And today I would like to talk about a plan of observations in the origin region of the Kuroshio. This is a pilot study for construction of observation system and a CSK-2 project. First, in recent years, we are facing serious issues. First is global warming, sea surface, water warming, in the Kuroshio region and other western boundary current region is very rapid compared with other regions here. And second is issue of marine debris. In the Kuroshio region, concentration of marine debris are extremely high in comparison with other regions. In addition to these serious issues, climate changes, as talked by Nonaka-san, and ecosystem changes, as talked by Saito-san, are also crucial issue or sustainable development. Because of these issues, Kuroshio and the adjacent regions are public concerns. We think that these issues which are responsible for, we think that's possible factors which are responsible for these issues are in the origin region of the Kuroshio. This figure shows covariance of sea surface water salinity with respect to that's in the Kuroshio extension region. The interannual variation generated in the east of Philippines propagates by about 9 months and reaches to south of Japan and to the Kuroshio extension region. We can suppose that, for example, the concentration of marine debris is identical to the movement of the interannual variation of salinity. So we think that the factors may be in the origin region of the Kuroshio, namely from the east of Philippines to the east of Taiwan Island, around here. So we focus on this region and have a plan to perform observation in this region. And knowledge about the current system in the origin region of Kuroshio is not enough to discuss variation of transport of materials, including marine debris and heat by the Kuroshio. So every time we perform observations in the origin region of Kuroshio, current systems is very different every time. So we aim to, we have planned to do observation in the origin region. The purposes of the observation is as follows. One is how the sea surface water in the origin region of the Kuroshio is modified. Second is the sea surface water is advected from the origin region to the east of China Sea or to the east of Ryukyu Island, which are possibly transported by the Kuroshio and the Ryukyu current, respectively. These studies lead to elucidation of these distributions of heat and materials in the Western North Pacific. Namely, that we can elucidate heat content variability and transport variation and salinity variation, and so on. Next, we introduce our ongoing observations. First, in December 2016, we deployed a mooring buoy at 13 degrees north, 137 degrees east here, around here. This mooring buoy has meteorological sensors on the top buoy, and subsurface sensors such as CT and CTD sensors around here from the surface of to the depth of 300 meters. In addition, this buoy has ADCP, which is facing to downward. This is correcting current velocity profiles down to a depth of about 400 meters. In addition, this buoy has 3 dissolved oxygen concentration sensors at the 3 depth levels. And so as a result, this observation can correct the temperature and salinity data like this. This is the upper panel shows temperature diagram with respect to time and depth. The lower panel shows salinity. This observation obtains clear seasonal variation here. And also we can see barrier layer seasonal variation as indicated by meshed layers here. In summer, barrier layer is very thin. On the other hand, barrier layer is very thick in winter. Like this, subsurface ocean data are well collected almost for all observation periods. But meteorological sensor observation is very difficult. We could correct 3 or 4 months after deployment. Meteorological observation is very difficult at this location. So next is this is our observation, ongoing observation. This observation started in December 2016. We deployed surface drifters with salinity sensors in 2016 and 2018. This is the result of the deployment. This one shows trajectories of drifters is directed toward the northwest. This panel shows also shows trajectory is directed northeastwards. This is unexpectedly different from our expectation. We expect that the drifters installed around here is drifted to the due west, but the drifters is drifted northwestward. So the current structures around here is different from our expectations. As we can see in these figures, observations around in the origin region of the Kuroshio is essential. More observation is essential in these regions. Further, we are planning to perform high resolution repeat observations in the Kuroshio origin region to observe how the current flows around here. We think that we do observations at a line from the Philippine Sea buoy to extending to the just east of Luzon Island, or from the buoy to south west. And also we should set a zonal line around the latitude of 20 degrees north because we want to monitor how the current across this line is converged to the Kuroshio and Ryukyu currents. But this plan, this observation is just a plan at this moment. The periods and locations of this observation is not determined yet. If we consider the recent difficulty of SIP observations, this high resolution repeat observation in the Kuroshio origin region of the Kuroshio cannot be performed by research vessels. So SIP observations are performed almost only by Japanese fisheries agency and meteorological agencies around here, like 137 East Line by meteorological agency and hydrographic observation around here by Japanese fisheries agency. SIP observation is very limited around here. So SIP observation seems not suitable for doing such high resolution repeat observation. So, so we expect new technologies to work well in the origin region of the Kuroshio. To perform high resolution repeat observation, we will use sail drones and web gliders in addition to traditional platforms such as mooring buoys, surface drifters, and RF floats. These traditional platforms are well known to be very useful to monitor ocean variability such as Kuroshio and other regions. But these new platforms such as sail drones and web gliders, with respect to these new technologies, we should have more experience to use these platforms well. We have to gain experience to use these new platforms. Because the Kuroshio is very strong, these vehicles will be rather drifted to downstream. So we have some experience for use of sail drones and web gliders in the Kuroshio regions and tropical and equatorial regions. This is an example of sail drone observation of the Kuroshio south of Japan. This is an experiment under the influence of strong currents. This is a map of satellite-derived SST. We can see a remarkably high SST region around here. So we try to observe air-sea interaction around here, and we use sail drones to observe this remarkably high SST region. The white line is the trajectory of sail drones. As a result, we can observe well the sea surface temperature, air temperature, and the difference, specific humidity, and the wind direction and the wind speed, and we can calculate turbulent heat flux like this. We find the interesting phenomena around here. Wind over the Kuroshio is significantly intensified like this. And associated with this enhancement of wind, turbulent heat flux over the Kuroshio is very large, like this. Although we have more experience to use these sail drones and web gliders well, we should have more experience. But anyway, sail drones and web gliders are very useful tool to observe Kuroshio. Finally, we discuss the contributions to environmental, socio-economic challenges in the context of UN decade. A knowledge based on our observation plan makes design of observation system to monitor changes of physical environment, such as current system changes, heat content changes, salinity changes, and so on. This knowledge from the observations contribute to climate changes, ecosystem changes, as talked by Nonaka-san and Saito-san, and also knowledge from the observations contribute to the solution of issues of marine debris through the identifying how heat and materials redistributed and identifying how and where debris converge. And also this knowledge contribute indirectly to predictive ocean, safe ocean, productive ocean, clean ocean, healthy ocean, which are the goal of UN decade. This contribution is indirect, but the construction of observation system is a quite fundamental contribution. I think very important plan, I think. And furthermore, knowledge based on the observations directly contribute to accessible ocean of UN decade. This is a direct contribution. We summarize our talk. We are performing mooring buoy and surface drift observations in the origin region of the Kuroshio from December 2016. These are ongoing observations. And future observation by using newly developed platforms such as sail drones and web gliders, in addition to traditional platforms such as research vessels, AlgoFlow satellites, and so on. We plan to conduct repeat high-resolution observations in the origin region of the Kuroshio. Knowledge based on these our observation make a design of observation systems. The constructed observation system will contribute to the achievement of goals of UN decade, indirectly to various goals of UN decade, and particularly contribute to accessible ocean of UN decade. Thank you.
Okay, thank you, Akira-san. Is there any question? Yeah, very interesting observation plan. Okay, yeah, please.
Hello?
Now, yeah. Hello?
Can you hear me?
Yeah, we can hear you.
Hi. Yeah. Hi, Eric, Akira. Thank you
Yes.
for your wonderful observation in the origin of the Kuroshio and for your nice talk. And I noticed that you mentioned that the drifters move northwestward rather than westward. So it's very interesting. And I'm wondering, how many drifters did you deploy in this region?
Oh.
And yeah, and I'm wondering, is the trajectory influenced by the mesoscale eddies or caused by the meridional change of the NEC bifurcation? Thank you.
Yes, we deployed 4 drifters two drifters around here and two drifters around in the tropical region. Totally 4 drifters were deployed. And another question is what?
I mean, yeah, so the second question is
Second
about
question.
the reason of the trajectory. Does that mean if the trajectory influenced by mesoscale eddies?
Yes,
or,
I think it's dependent on it's responsible for mesoscale eddies or submesoscale eddies.
Mm-hmm. And maybe it also can be influenced by the meridional displacement of the NEC bifurcation. I mean,
Yes.
for example, yeah, it's the northward change of the NEC bifurcation latitude. Do you think so?
Yes. Around here, previous studies show that these regions is activity of mesoscale eddy is very high, and and in the lower latitude, activity of mesoscale eddies a little small. So the meridional change is very responsible for these trajectories. Yes.
Mm-hmm. Okay. So do you plan to deploy more drifters in this region?
Yes.
I mean, yeah. I mean, if you have more drifters here, then you can see the statistical features of the trajectory.
Yeah.
Maybe. Mm-hmm. Thank
Yes.
you for your.
Thank you
for your reply. Thank you.
Okay. So is there any question? Is there any question?
Okay.
Yeah. Okay.
Yeah. Okay.
Yeah.
Yeah. Look at the list. Sanhyun now.
Oh, now I had already asked his question, I think.
Oh, okay. May I ask a question?
Oh yeah, sure. Okay.
Okay. Thank you for introducing this relatively new observation program, and I think this program is more relevant to my previous question. Since your mode buoy, the pH buoy, is located in the tropical area where the typhoon, some typhoons can be generated, and regarding to the safe ocean for the ocean decade, decade of ocean science, the typhoon is a very important process to better understand. So, do you have any plan to operate your sail drone and wave glider in and around this pH buoy in the future to collect the data to estimate the turbulent heat flux under typhoon condition and to compare the result with numerical study of previous speaker showed?
Yes. This is an example. We have performed sail drone observation around the pH buoy, or I have already done, and calculated turbulent heat flux by Anderson. And we can collect very well data around pH buoy data, pH buoy. So
you can, yeah.
Yes. As you said, our buoy observation as directly contribute to a safe ocean. Thank you. I agree with you.
Yeah. So now you have experience to operate your sail drone and wave glider in that area.
Yeah.
So now you can also operate this in the area around the PHV
Yeah.
in the
Yes.
future, right?
Yes.
So,
Already. Yes.
so when the typhoon is generated, it will collect very nice data set to estimate turbulent heat flux, right?
Yes. That's
And
at this moment, sail drones and web gliders escape from typhoons because very easily destroyed by strong wind and strong waves. But so we have more experience to observe air interactions under a typhoon or such a strong wind condition.
yeah, it seems like you estimate rather than directly measure these turbulent heat flux using something like bulk formula.
Yes.
Meaning your mode V does not equip some flux measurement sensor, right?
The number of V's is limited to deploy. So the comparison between V data and sail and the web gliders will be only around PHV. It's answer for your question.
Yeah. So if you add more sensor for flux, I mean, if you add flux sensor to the mooring mode V, then it will be better to be used in the future for this kind of data set.
Yes, I think so.
Okay, thank you very much.
Thank you.
Thank you. So Lily, please go ahead.
Okay. So Akira-san, I think it's a very impressive talk. So and also I'm very glad to see your group of King Ando's group are still continuing your observation in the tropical Pacific. Besides of the Triton buoy, and I think this one is a new site, right, from 2016, something like that. And actually, I just curious about in your first few slides, you talk about the salinity signal, how the signal propagated from the tropical Pacific to the Kuroshio extension area. But in most of the cases, when we talk about this thing, we usually use the velocity or transport. So I just curious why you use salinity here. This is my first question. And I also have another comment. Another comment is about the shift time. I think the observation in the origin region of the Kuroshio is not only the shift time, it's not only the cruise, because in recent years, China, Korea, we have several cruises there, but we have some trouble in conducting cruise especially near the Philippine EEZ. So I think the EEZ issue is more challenging than the shift time. So I'm not sure Professor Cesar Villanoy is not here. Maybe he's here or not. Maybe we can talk about it in the future or sometime about the easy issue, because that is very important for us to get the data in the origin of the Kuroshio. Okay, thank you.
Yeah, thank you. For the second question, I agree with you. Easy problem is very important to collect good data in the origin of Kuroshio. For the first question, the movement of salinity variation is quite slow in comparison with Kuroshio current. I think that this is transported by dual current systems and as a current other than Kuroshio. Part of the signals transported by the Kuroshio, but the part of the signal is transported by other currents, such as dual current system. Dual current system, current speed is something like this movement.
Okay, thank you. So Wenxi. Hi, Wenxi.
Thank you, Xiaopei. This is Wenxi from Bangkok WESTPAC office. I have been, considering, how to link all those crucial related study into the future CSK-2, particularly under the framework of the UN Decade of Ocean Science. I'm still thinking, I'm sorry, I still couldn't find a very good solution at this moment, but I do wish to draw all of us attention to the importance that the UN Decade wish to facilitate, the uptake of data, information, and the resulting knowledge for policy decision-making and the management and the innovation. I think so far, most of our dialogue or conversation focus very much on observation and the process study without much, consideration about what kind of knowledge could be generated to serve the policy decision and also management issues. I think there's something we need consider more if we really wish to have the CSK-2 under the framework of UN Decade Ocean Science. UN Decade Science or Decade for Ocean Science is not the decade for ocean science only. It's a decade of ocean science for sustainable development. So there is some new way of approach to marine scientific approach. We always say observation is very important. Yes, every observation, every monitoring can be contributive to many different socio-economic, objectives, but we cannot, in most cases, we cannot do almost, all kinds of observation at all kinds of temporal and spatial scales. So this is something I think our group need to consider more and seriously. I think the CSK-2 webinar has already gone half. Whether we can have one concentrated session with a focus on how to develop the science action of CSK-2, because currently that focused session is not in the agenda yet, not yet. So this is my proposal for this meeting. Yeah, thank you, Xiaopei.
Thank you, Wenxi. Yeah, I think it's also very important. So, okay, is there any other question? Okay, do you have any question or comment?
Oh, sorry. So no. So I'm also co-author of this presentation, so I don't have.
Oh, okay. So I think if there is no question and also it's nearly time, also could you show your face for everyone, and so we can have a group photo for everyone. Yeah, please show your face.
I didn't see mine. Huh?
Okay, so thank you everyone, and so we have a very fruitful webinar, and we also expect next time. So see you next Friday. Okay.
Okay.
Okay. Bye.
Okay.
Bye.
Who took photo? Who took
Yeah,
photo?
photo. Yeah. Take
Did you?
Yeah.
Choppy, did you take a screenshot?
Okay.
No?
Could you do it?
Yeah, I can do that. Yeah. Okay.
Okay. Yeah.
Okay. So everyone, please come up to the the camera and say hello.
Cheers.
Cheers.
I'm going to
Okay,
have a cup of beer. Cheers.
3, 2, 1, 0. And going to the next page, or only 22, 1. Yeah, this is fine. Yes, I finish. Thank you.
Okay, thank you.
Okay,
see you next time.
have a nice
See you
weekend.
next
Thank
week.
you very much, Choppy, for chairing session today. Right.
Okay, thank you all.
Right.
Yeah.
Mm.
See you. Bye.
Thank you.
Thank you.
Thank you.
Thank you.
Thank
Bye.
you. Hi, Nachapa.
Nachapa.
Hi, Misu.
It's been a long time.
Hi, Misu.
You fine? Hi, Macy. Hi, Somcat. It's nice to see you.
How
Even
are you?
online.
How are you?
Yeah, good. Thank you.
Yeah.
Bye.
Bye.
Nice
Bye,
weekend.
bye.
Have a nice weekend. You too.
Yeah, nice weekend, Misu.
Take care.
Take care, you too.
Thank you.